Hi, my name is Michael Casali, and I'm going to be focusing on tidal power. The picture on the right is a tidal generator that's found in South Korea. For my proposal, Congress is going to mandate the change from fossil fuels to tidal power by 2070. Current power production in the US is mostly generated through natural gas, nuclear energy, and coal. Each one of these has separate drawbacks that some are greater than others. Natural gas is found by drilling through pockets of shale, and then it's pumped out and transported to your power generators. Coal needs to be mined, and as well as uranium also needs to be mined, and then those both need to be transported to their separate generators. Each one of these three increases our carbon footprint when we generate power. 20% of all of our electricity is from renewable sources, and this number definitely needs to increase. Our current consumption needs as of 2021, we consumed about 3,930 terawatt hours, and 20% of that was 786 terawatt hours, which were produced by renewable sources. The 3,930 terawatt hours represents a 2% increase from 2020, where we only used 3,144. This means that the power grid definitely needs to expand. We need more infrastructure to carry power from the generators to your homes, as well as we need more generators. The global electricity demand, it grows about 2.1% per year, which definitely fits the 2% growth in the US. This is the growth in power consumption can be attributed to multiple factors. One of the chief ones is as population increases, so does our power consumption. And also, as more civilizations get more and more modernized and we have more and more technological advances, we're going to rely on power more and more to run things like machines and even cars or different electrical things. Some of the alternatives that help relieve our carbon footprint are wind, solar, and hydroelectric. Hydroelectric does include tidal power generators, but for this, we're just going to focus on dams that are more inland. Each one of these has separate drawbacks, and wind power and windmills have a relatively short lifespan. The windmill blades are also difficult to reliably recycle, and most of them get buried in landfills or they just get stored in landfills. Windmills also can kill migratory birds if they're placed in migratory pathways. And another drawback from wind and both solar power is that they can be unpredictable. Solar power generation is expensive to install, but it's relatively fast to install depending on which ones you use. Solar panels also take up a lot of space, and to completely power the United States, we need about 22,000 square miles of solar panels. And as I said, these can be installed fairly quickly, which is a positive. Hydroelectric power has its own drawbacks. It severely impacts its environment, and it's very location specific. You can't place it near a fault line, and you have to find a river to place it on. Current alternative power sources have limited power generation capabilities, and a new alternative needs to be found. In my talk, I'm going to be focusing on tidal power, which is converting rising and falling sea levels into power, or converting the tide into power. The tide will come in twice a day. Two times you'll have high tide, and 2 times you'll have low tide. Both are opportunities for tidal power generation depending on your tidal power generator. On the right, you have a tidal power generator that is more like a dam, whereas the tide goes up, it fills both sides, and then one side goes down, and the other side will slowly flow out through a turbine and generate power. On my upper left, I have a generator that is more like a windmill, just in water, and as the tide goes up and down, it spins the turbine. On the bottom left, I have what's called an artificial blowhole. As waves and tide increase, it's forcing air out the top, which spins the turbine, and as it decreases, it sucks air back in, which also spins the turbine. For my first affirmative argument, tidal power can help slow global warming. It won't stop it because there's not enough tidal power to be generated. And in the picture on the right, you have our metric tons of carbon that are produced. And as you can see, it drastically increases after 1940 and continues to increase until the edge of the graph in 2010. And this can be attributed to fossil fuels, which are one of our largest sources of greenhouse gases. And from 1940 to 2010, it also follows a rapidly industrializing society. For tidal power, estimated total tidal power production is about 120 to 400 gigawatts. This is a little bit on the conservative end, but it's definitely realistic. And it's a good goal to set. With all of the alternative forms of energy currently, we can offset about 1.5 million tons of CO2. One of the most important things about tidal power is it's very predictable. No other alternative source of power really shares this factor with it. And this is because you get a high tide and a low tide twice a day. We can also predict tides up to 2 years in the future. We can predict the time that the tide will be high and low, and we can also predict how high the tide is going to be, which is very important for power generation because then you can factor those two things into how much power you're going to generate. Depending on the power generator too, you can generate power at peak hours of demand. So you'll always be generating power when people are using it the most. Tidal power is definitely going to vary with the tide by definition, and the predictable power is going to be drawn out over its long lifespan. So you have a large rate of return because their lifespan is about 75 to 100 years. Tidal power for in my affirmative argument 3 is it can be placed on unusable coastlines. The picture on the right is from San Francisco, and it's a cliff. And if you place a tidal power generator here, it's going to minimize human impact. And unlike a coal generator or a nuclear generator where they're larger and coal generators produce smoke or steam, the tidal generator can be placed with a minimal impact on humans. And some can be placed beyond eyesight out in the ocean, like the turbine one. Another advantage of tidal generators is about 40% of the US population lives along coastlines. This is a double-edged sword though. Tidal generators are definitely location specific, and if you look to the right on the map, you can see that all the areas in red are areas that have a really high population density. Tidal generators and these are generally on the coast, and tidal generators can help alleviate the power consumption in these areas. But with the 40%, that means 40% on the coastal areas, that means that 60% live in non-coastal areas. So tidal power is definitely limited just to supplying the coastal cities. Tidal power can only also be applied in locations with really high tides. It's not going to work if the maximum height of the tide is fairly low. Tidal power is also best used in fjords or narrow bays where you don't have to build a large dam across a huge area to help generate power. This does depend on the type of generator. For my second negative, there's a very high cost associated with tidal generators. Tidal power generators are difficult to install, especially the dam version ones. You can't divert the ocean like you can a river to build the tidal generator. And they also require extensive maintenance because salt water is very corrosive. Research is also going to be required to help improve designs of tidal generators. These generators need to be more efficient to be appropriately used along coastlines. And another thing to factor into cost is more money is going to be needed to research an efficient generator, and the money, it might be just a sinking fund because you could invest a bunch of money and then not have a generator at the end of it. Another thing to consider is the environmental impact. Turbines can kill or injure wildlife. This is true for both outside and inside the water. To the right, I have a windmill, and this windmill is placed where a lot of birds are flying, and this is going to probably kill a few birds. If a turbine is placed in an area where there are a lot of fish, undoubtedly fish are going to get sucked into the turbine. They're also going to die. Tidal generators, depending on the type of tidal generator, have been proven to impact tides over a very large area. There was a study conducted in Canada where they wanted to place a tidal generator, and they found that if they placed it, it would impact tides all the way in Maine. Environmental impacts are also not fully understood. This means that more research is required, which is also going to increase the cost. In summary, power generation is limited to coastal cities with very high tides. This means that your more inland cities aren't going to be as affected by tidal generation. An attribute of tidal power generation is they provide reliable, renewable, and predictable sources of power, which is hugely important for a growing city. Tidal power generators are going to require years of expensive research, which may not reveal anything fruitful at the end of it. And they are expensive to maintain, and the environmental impacts are very poorly understood, so more research is going to need to happen. Thank you. To my right, I have another picture of the tidal generator in South Korea.